In this session, we will see one more example related with relative Cartesian coordinates method. Now let me take the second figure. Now we will see how to create this figure using the relative Cartesian method. Already we have seen using the grid and absolute methods. Now let me go with AutoCAD, and here first we will set the limits. The lower left is 0, 0, and the upper right let me take as 15, 15, because the maximum dimension is 13 in that figure. So go with 15, 15. Then after setting the limits, you can go with Z enter, A enter. So limits have been set here. Then let me go with line, L enter. And in this relative Cartesian method, you can start from anywhere. So I can pick a point anywhere on the screen. Then now let us think that I am starting from here, and if this is origin, then the next point coordinates will be 4, 0. Then here you can go with @ to consider that point where you are standing as origin. You can go with @, then you can specify the coordinate values as 4, 0. So this is the line we got. So now I am standing here, and if I treat this particular point as origin, then the next point coordinates will be 0, 3, because from here if I calculate up to this point, there is no horizontal movement, we have only vertical movement. So you can take this point coordinates as 0, 3 if I consider this point where I am standing as origin. So let me go with now @ 0, 3. Then we will go to the next point. Now I am standing here, so I have to consider this one as origin. If this is origin, then this point coordinates will be 5, 0. So let me go with @ 5, 0. Then again I am standing here right now, so you can take this one as origin. If this is origin, then this particular point coordinates will be 0, -3, because from here I am moving in the negative of y, so you can take -3. So let me go with @ 0, -3. Then right now I am standing here. If I am standing here, then the next point coordinates will become again 4, 0, because now I have to consider where I am standing as the origin. So if this is origin, then the next point coordinates will be 4, 0. So let me go with again @ 4, 0. Then now we will try to create this vertical line by specifying the top vertices. Now here at this vertex, at this point, let me specify the coordinate values as 0, 9, because now I am standing here, so this is the origin. Then this point coordinates will become 0, 9. So @ 0, 9. And right now I am standing here, then this particular point coordinates will become -4, 0, because I have to move in the negative of x. If this is origin, from here I have to move in the negative of x, and this is -4, 0. So let me go with @ -4, 0. Then I am standing here, so this particular point coordinates will be 0, -3. So this is 0, -3. Let me take again @ 0, -3. In this point coordinates you can take it as -5, 0. If you are standing here, then this next point coordinates will be -5, 0. At the rate -5, 0. Then this point coordinates will become 0, 3, because now I am standing here, so this will be 0, 3. At the rate, we go with 0, 3. Then let me go to the next one. So this point coordinates will be again -4, 0, because I am standing here, so I have to move in the negative of x, so -4, 0. Let me go at the rate -4, 0. Then now I have to reach this point, and from here if you take the coordinates of this bottom point, it will be 0, -9, because I am moving in the negative of y. So let me specify here at the rate 0, -9. Now we can go with escape. So with this the total figure is completed. So this is about relative Cartesian coordinates method, where we are specifying the next point coordinates by treating the point where we are standing as origin with the help of @ symbol in front of the coordinate values. So this is about the relative method. Then next we will see about the relative polar method, the relative polar coordinates. So, and this relative polar coordinates method is used to create inclined lines. So whenever you want to create inclined lines, you can use this relative polar coordinates method, and for that there is a syntax, and the syntax is @ we have to specify the length, then go with the less than symbol and specify the angle. For example, if I want to draw a line of 50 mm at an angle of 35 degrees, then I can go with @ 55 less than 35. So what are the length you want to specify, you can specify here. If I want a line of 100, then I can go with @ 100 less than the angle. So that is the syntax which you have to specify. Now I will show you an example. Let me take a line, I'll enter. When it is asking specify the first point, you can pick the first point anywhere. Then from this, if I want to draw a line of 10 units, that is the length of the line I want to be 10 and the angle is 60, then you can go with @ from there. The length is 10, so let me go with length 10, then go with less than symbol and specify the angle. Angle I am giving here 60. So this is the syntax @ length less than angle value. So specify it, then go with enter. Now you can see this is the line which we got at an angle of 60 degrees from the horizontal. This is 60 degrees and the length of this line is exactly 10. So this is called relative polar coordinates method. Now once again I am going to line. Now let me pick the start point. Let me go with @ from there. I want a line of 5 units at an angle of 30. So let me go with less than and 30. Now this is the line. So this relative polar coordinates method can be used only if you know both the length as well as angle. If I know the length and if I don't know the angle, I cannot go with relative polar coordinates method. Similarly, if I know the angle and if I don't know the length, then also I cannot prefer it. So both the parameters are compulsory in case of relative polar coordinates method. And after completing this, now next we will go with the last method and the important method, which is called direct distance entry method, or even you can call it as DDE method. DDE means direct distance entry method. Now in case of direct distance entry method, directly you can specify the direction in which you want to create the line. You can show the direction and then you can give the length of the line as the input. So for example, if I want to draw a line of 10 units horizontally, then I can show the horizontal direction and I can specify the input as 10. Automatically a line will be created of length 10. One example we will see here. Let me go with line, I'll enter. I am starting from here. Then I want to create exactly horizontal line. So let me switch on here ortho. Now in this direction, that is towards right side, I want a line of 5 units. So I am giving the input as 5 and go with enter. Now you can see we got a line of 5 units horizontally. And similarly, I want a line of vertically towards top. So show the direction towards top and specify the length as 6.5 and go with enter. So here we got a line of 6.5. Then horizontally again I want on the right side a line of 2. So I am going to enter. Then this is a 2 units line. Then vertically towards bottom I want one more line. So let me show the direction and I am taking the distance as 8. So this is 8. Then now horizontally towards left side I want one more line of 7. So I can go with 7 and enter. So like this you can specify the distances. So this is about direct distance entry method. Now we will see one example here. Let us take the first one. Now this one I am going to show you by going with direct distance entry method. I am going to line. Let me select here from the draw toolbar, pick the first point and we have a line of 13, so you can show the direction towards right side. I am giving the input as 13, go with enter. Then towards top I want a line of 8, so I can show towards top and specify the input as 8 and go with enter. Then again left side I want one more line of 13, so show the direction towards left and give the input as 13, go with enter. Then towards bottom I want one more line of 8, so show the direction towards bottom and specify the input as 8 and go with enter. Now you can go with escape. So this is the result we got. So no coordinates, nothing, directly you can specify the length of the line by showing the direction, then the lines will be created. So this is called direct distance entry method, and few more examples related with this we will see in the next session.